This question is taken from the NSAA 2020 Section 1 paper, and it is question 34 of the Physics subsection. A car of mass 800 kilograms accelerates from rest for 5 seconds, non-uniformly, and then moves at constant speed as shown. So this is the distance time graph. What is the average force on the car during the time it is accelerating? So we're looking for the average force during this period. So the average force should just be equal to the mass times the average acceleration using Newton's second law, so F equals ma. So this is a simple relationship that we should think of automatically. So we know the mass, so the problem will just be getting the average acceleration. So how could we get this? Well, just like average speed is the total distance divided by the time, then the average the average acceleration will be the total change in velocity over the total change in time. So it does not care about what the acceleration was at any point in between, just the total change in velocity divided by the total change in time. So this change in velocity is then what we need to find, because we know the change in time is 5 seconds. So the change in velocity is the final velocity at 5 seconds minus the initial velocity, which was 0. So how could we get the final velocity, which is here? The question does mention that it moves at a constant speed after this period when the force stops acting. So we can work out the final velocity as it carries on here, because we know that the velocity on a distance time graph is the gradient. So if we calculate this gradient, we have 30 divided by 5, so the change in distance over change in time. So this velocity final is 6 meters per second. So if we put this into our equation for the force, then we have 800 times 6 divided by 5. And then a simple cancellation will be 800 divided by 5 is 160. So if we times this by the 6, we get 960 newtons as the average force. So 960 newtons was the average force acting on the car during this period of time.